Hello. Hello everyone. In this video, I go to introduce the solution for LeetCode biweekly contest 104. There are 4 problems. The difficulty is 3, 4, 5, 6, and we may iterate each problem one by one and go to explain what is the solution for each problem. For the first problem is so we are given a string like this, and in this string, what we are really interested is on the characters to indicate the age of the person, and the result is if there's some passenger that is strictly more than 6 years old, then we should update result with by +1, right? So the result will indicate the number of passengers who are strictly more than 6 years old. So this problem has a very direct solution. It's like we iterate each of the passenger in this vector, and we make use its 12th and 13th character to calculate this passenger's age, and if this age is more than 60, then we +1, and we finally return the answer. Second problem is called sum in a matrix. The problem is like we are given a matrix, and we may do operations like so first of all, and for each row in the matrix, select the largest number and remove it. In the case of tie, it doesn't matter which number is chosen, and identify the highest number amongst all those removed in step 1, add the number to your score. Okay, so it's a the problem actually looks I'm not sure how about you, but I feel a little confused when I read this problem. But finally, the problem actually looks like in this way. So for example, we just use the first example as a case, right? So we have 7, 2, 1. We have 6, 4, 2. We have 6, 5, 3. We have 3, 2, 1. So the problem is actually for the first step 1 for each row. Actually, row means this is a row, and this is a row. And for each row, it selected the largest number and remove it. Then in this row, 7 is the largest number, and we select 7 and remove this. So we remove the 7, and in this row, we should remove 6, right? So we remove 6, and this remove 7. And for this row, we remove 6, and we remove 6. And for the last row, we should remove the largest one is 3, so we remove 3 here. And these are removed. And in the removed elements, we select the largest one, that is 7. So we +7 to the score. And then this is the first operation. And the second operation is same, like we select 2 and remove it, select 4 and remove it, select 5 and remove it, select 2 and remove it. And also 5 is the largest number in all of the removed numbers for this operation. So first step we +7, second step we +5, something like this. Actually, this is also a direct solution. First of all, we sort, right? So sort, we just want to select the maximum number in each row. So we sort each row, and reverse, then we make the largest number at the top and the smallest number at the bottom. And then this just simulate each step. We select the, first of all, we remove the elements from each row and select the biggest value in the removed numbers for each step, and update this, add this value to the final answer and the return answer. Okay, so this is the second problem is it's actually still simple and direct. Okay, so next problem. For this one, we are given a zero-indexed integer array names of length n and integer k. And for each operation, what we can do is we select one element in this array and multiply it by 2. And after we can make at most k elements, and then we bitwise all of the elements in this array. It will be the result. So we want to get the return the maximum possible value, right? So we want to make this value as big as possible. Okay, so for this problem, first of all, we should understand that for this operation, right? So it can take at most k times, and this operation should be applied on the same elements in this array. And because you multiply elements by 2, right? So this element is bigger because it's a bitwise shift to the right side by one element, right? So this elements, after you multiply it by 2, then this element is definitely bigger than all of the other elements in the array. So you should further increase the same number. It doesn't make sense that you go to make these elements on the other elements, right? So these operations must be applied on the same elements. This is the first observation. And the next one, the idea here is like, for example, we have 4 elements. For example, that we have nums. We have num0 and num1 and num2 and num3. And for each time, for example, we select one element. For example, select the first element. We multiply these elements by 2, right, for k times. And after we make this operation on the first element, we want to bitwise all of the elements now. If we can make this process quick enough, actually we can just iterate each element and simulate the process and get the result, and then we can compare the result to know what is the maximum result we may get, right? So now the problem is how we can, so after we select one specific element to make this operation, how can we calculate the final result based on this operation? Okay, so for this one, this problem actually has some tricky skills. Let me try to explain this. Maybe we can see the code, and meanwhile I can try to explain the idea before the code, right? So this code, first of all, we define 2 variables. One is a single bit, another one is multiple bits. And first of all, for single bits is it's just we bitewise each element to the single bits. So for single bits, so let's see. So here we have single bits. For single bits, if some position's value is 1, it just means there is at least one element in the array has bit 1 on this position, right? So this is a single bits meaning. And for multiple bits, so here we also have another variable named multiple bits. For multiple bits, if some position's value is 1, so this means there are 2 or more elements has bit of 1 on this position. So it has 2 or even more elements has bit 1 on the same position. So that's for the meaning of multiple bits. And how do we calculate multiple bits? So we make use of single bit. So first of all, for multiple bits, right? If there is a position already 1 on multiple bits, then it's always 1. That is why we, here we just multiple bits, bitwise or itself, right? So that is there is 1, then it's always 1. And also we make use of single bit for the result of all the numbers before current number. That if single bit some position is 1 and the current number's position's value is also 1. So we can set these positions bit as 1 for the multiple bits, because that means there are at least 1 element before has a bit 1, and also current number also has bit 1. So we can set multiple bits as 1. Otherwise, that either the numbers before current number, the position is 0, so means no elements has a position 1 has bit 1 on this position, or the current number's position is a bit 0, not bit 1, right? So in this case, we cannot update multiple bits. That's because there is the current number cannot contribute to this position. That's because we don't know there is two elements has a bit 1 on the same position. So this is how we calculate multiple bits. And after we have single bits and multiple bits, so this is the final answer, and this result is the local answer. Local answer means after we select the ith elements to be applied with this operation, what is the answer based on the selected elements. And so first of all, we single bits and the current numbers, we get this reverse. So reverse the current numbers bit value and end with single bits. So that means if the current number's value is 0 on some bits, right? And for the single bits, if the same position, the bit value is 1. So that means this is 1. This 1 is contributed by other elements because the current number's bit value is 0, right? So this 1 must be contributed by other elements. In that case, we can say the final result should have bit 1 on this position. And also we can bitewise or the result with multiple bits. This is because we have 2 or more elements has bit 1 on this position. So that is even we select the the elements to shift, but there is also other elements has bit 1 on this position. So that is why we can also assert the final results bit value on the position should be 1. So that is why we can do this. And after this, we just right shift the current numbers by k position and update this value to the result. So this should be the final result after we select one element and make operation on it. And we calculate this result with the final answer to get the bigger one to update to final answer and return this answer. Yeah, this problem is a little tricky, but you can think about the the ideas before the ideas after this logic. So I think you may understand why we can use this way to calculate the result quickly. Okay, so next one is the final problem. But this problem is like we are given a integer array named nums, and the power of a group is defined like if we have k elements in one group, then we go to use the maximum value of this group and power 2 and multiply with the minimum value of the group. And this is the power of group. And for this array, right, so it can have multiple groups. And we want to calculate what is the power of all non-empty groups. And this value is big. Then we model by 10 power 9 plus 7. Okay, so for this problem, it's a little something that we should try to observe what is the rules to calculate the result quickly. So we can make use of the first example to explain the ideas after this code, right? So for the first example, we have the nums 2, 1, 4. And first of all, let's sort this array. So we have this array like 1 to 4. This is a sorted array. And we can start from the first element to see how we calculate the score. And so here, first of all, we start from the first elements. And for the first elements, it should have, so first of all, the group can only contain the first elements, right? So first of all, the score is like the score calculated based on the only elements in the group. And the next one is we may go to calculate the second elements. And for second elements, first of all, it also can have just one element, so the value should be 2 power 2 plus 2. And then we can think about it can build a group with the first element, right? So now, because this is a sorted array, so the maximum element is not changed. And now it's the minimum element is changed to be 1, so it's like this. Okay, And then now we go to calculate the third elements. So first of all, it also has the elements like this. So this is the group. Just have one element. And the second, these elements can build a group with the second element, right? So it's like this. So this is their score. And the next one, these elements can build a group with these elements plus any element that is bigger than the first element and smaller than the third element. So there is only one element, right? So it should like this. So this is the group's score because the maximum and minimum value is not changed. It's 4 and 1, right? So this is the score. And now the question is, how many groups like this? Like there is only one element between them. So the group can be, first of all, there is one element. I can select none of the elements. So that is just 4 and 1. And I can also select one element. So that is I select 2, right? So the group will be 4, 2, 1. Okay, so this is the score based on the the third elements, right? So now let's add another elements into this array, just to observe what is the rules we may have here. And for this one, first of all, it's also 6 power 2 by 6. So this is for the group, only has these elements. And the second one, these elements build a group with 4. And it's like, right? And the third one, these elements build group with 2. So it's like, okay, now the question is, how many groups we may have? So we may have like this, right? Because there is only one element between them. So I can select 0 or I can select 1. And last, these elements can build a group with element 1. So it's like plus 1 plus. And now there are 2 elements here. So I can, select 0 elements and select 1 element and select 2 elements. It's like this. Okay. So now we can see there are some observations we can make, right? So for each element, we can see it's always so except for the first element, right? It also always have 2 elements like this. So one is based on the element's value itself, and the second one is based on the elements just before these elements. So this is the score for each element. And secondly, we can check the value like this. And first of all, please know like for these values calculate, right? So what I mean is for 0, n1, for n0, n1, and plus nn, this value is 2 power n. So if you don't, you want to understand how to, how to prove this, then you can Google it. So basically, there's not difficult to understand, but so here we will make use of this. Okay, so for this one, actually this means 1, right? So this is 2, 1. This is 2, 2, and we can see that for these elements, right? 1. So in the next elements, actually, this value is multiplied by 1. And also for these two, so this two is 1 in oh sorry, so this 2 is 1, right? So here is 1 on element 4, and now it's multiplied by 2 in element 6. So this is also multiplied by 2. Yeah, so this is actually the rules we should check, right? So for each of this value, it's multiplied by 2. And we can think about such like if we have another element on this array. For example, if we have 9 here, then we can think about this value is first of all based on the element itself. It's 9 power 2 by 9, and it also has 9 power 2 by 6. So this is based on the elements before it. And next one is 9 power 2, right, by the elements before it, by 4. And now here is only one element, right? So this is by power 1. And also next one is 2, right? There are 2 elements between them. So this should be 2 power 2. And the last one is there are 1, 2, 3. So this is will be 2 power 3. And based on the result of element 6, you can see 1, right? 1. So before it's 2 power 2, now it's 2 power 3, and 2 before is 2 power 1, now it's become 2 power 2, and for this 4 before it's just 2 power 0, and now it's become 2 power 1. So that is for each value we can just multiply by 2, and based on the result to calculate the result of the next elements. Okay, so now we can go to check these codes. Like first of all, we go to salt, right? Salt, and we have 2 values. This is the final score, and this value is actually it's the it's the value of current elements value like this, and we start from the first element. And this multi value is just means based on this power, right? How much value of the I should multiply with power of current elements. And first of all, it's this multi value has the element itself, and it's also if this I is bigger than 0, it also has the elements before it. And also it's a plus value. So value is actually the so this the first 2 elements, and the value would be all of the other elements calculated by the previous element's value. And after this, I go to calculate square of current elements, and then adjust the power of current elements by this multi-value and add it to the final answer. And here I go to update value, right? So value first of all is need to add the current the previous elements. It's just like for 6. Here I should add 4, right? And for element 4, I should add element 2. And for element 9, I should add element 6. So this is why I first of all add the previous element to value, and then I multiply value by 2, and then this value can be used in the next iterator. and then just return the answer. Okay, so this is all of the solutions for LeetCode Biweekly Context 104. If you have any questions, please let me know. Thank you.